All right, we're going to finish up our work on compound inequalities by looking at a challenge problem. Not so much a real-world connection for this example, but I think it is a good challenge problem here. And the question is, what is curious about the following compound inequality? So we have 3x plus 2 is less than 11, or negative 4x plus 3 is less than 7. And nothing strikes me as curious just looking at it at first, but let's dig into it a little bit and see what we get. So I'm going to solve these two inequalities separately, and we'll see what we end up getting. So I will subtract 2 from both sides here, and I will separately subtract 3 from both sides here. And that's going to turn into 3x is less than 9. Okay, no problem there. And a negative 4x is less than 4. Okay, so far so good. Nothing is really jumping out at me yet as being curious, but let's keep going. We'll divide this guy by 3, and we'll divide this guy by negative 4. Okay, these 3's cancel. X is less than 3, and that part is done. These negative 4's cancel. We have to flip the sign because we divided by a negative, and we have an or in between here. X is greater than negative 1. Oh, I don't know if you see it, but I see it right here. X is less than 3, or x is greater than negative 1. If you don't see it yet, maybe we could draw out a number line here. And I'll start with a negative 2, negative 1, 0, 1, 2, 3, 4. And I am going to try to do a little bit of color coding here to help you see what's going on. So I'm going to circle that one in purple. X is less than 3, and I'm going to put my arrows just slightly above or below the number line. Actually, all above the number line, so you can see what's going on here. So x has to be less than 3 is what the purple one says. And then let's do a green one here, or x is greater than negative 1. Do you see it yet? What's going on is that x can be anything. Okay, x can be any real number here. Every real number in the world is either less than 3 or greater than negative 1. Okay, there are a few numbers in this solution set that sort of fall within both categories, but keep in mind we don't need both categories to be met. It's not an and problem, it's an or problem. So we just need either purple or green to be met. So x is any real number. All right, that's a good place to stop right there.